Okay, polynomial functions. Polynomial function means that we can write it as a sum of power functions, and that n has to be an integer greater than or equal to 0. Alright, so we are going to determine if each of the following. If yes, we're going to give the degree and the number of terms. If no, we're going to explain why not. Actually, I'm not going to explain why not. I'm not going to write it down. So our first one, remember, we have to remember that n has to be an integer greater than or equal to 0. So we've got the number is 4 and 2. Oh, might not be a polynomial. Oh, wait a minute. We can write it down as x is 0, and that is equal to 0. So yes, it is a polynomial function. And because we have 4 as our highest power, our degree is 4. And we have 3 terms. We've got the term that has the 3x to the 4th power. Our second term is 6x squared, and our third term is negative 5x to the 0 power. So we got 3 terms. All right, that one, square root of x. No, because we cannot write it as a greater than or equal to 0. A square root is a fractional value, so it's x raised to the 1/2 power. So no. Alright, what about this one? Well, we have a part that is a negative 4. Negative 4 is not greater than or equal to 0, so no. Negative 4 makes it a rational part. Alright, now over here, here's another rational one. X can be written as x raised to the negative 1 power, so no. Alright. Absolutely no. No. Not a polynomial function, because n has to be greater than or equal to 0. Alright, just because something is a ratio does not always mean that it is not a function, it's not a rational function. Here we have that x can be raised to the 1st power, and we can actually write that as 1/3 times x subtract 5. That's just a linear function in a funky dress. Alright, so now we're over to 6. Well, we're going to see if we can factor this. If we can factor it nicely, we might be able to divide out some items and get rid of our denominator. If we can factor nicely, then we'll move on to, we'll use our calculator and see what happens. Because a polynomial, I'm thinking it's going to be a rational function. So let's take our negative 15, because we're going to take 3 times negative 5, because we don't have any common denominators. We don't have anything that we can factor out. We got 3 and 6 and negative 5. Alright, I don't see anything that adds up nicely to give me the middle number. So, that means if I don't see where that would divide. None of my things is going to be a positive or negative 2. Not going to come out nicely at all. I'm going to say right now it's a no. Alright. Let's look at this other one, number 7. I'm going to say that's no for right now. We might want to play around with that, use the quadratic. Well, we can't even use the quadratic function. You guys have not done long division of polynomials, so we can't do anything with number 6 right now. We will readdress it later, though. Alright, number 7. Just because we have parentheses and stuff like that, we can see that we got 5x, which is raised to the 1st power, and then when we do what's in the parentheses, it's going to be x squared, and when you take a first times a squared, you're going to get x cubed, so our degree is going to be 3. When we expand this, we're going to get a trinomial. We're going to get an x squared term, we're going to get an x term, and then we're going to get a constant term, and then we're going to multiply it by 5 over x, 5x, which then makes it 5x cubed times our middle term of negative 6, which would make it a negative 30x. And then if you take 5x times 9, you're going to get 45. So we're going to have a degree of 3 because we have x cubed. And we're going to have 3 terms. So we've got a degree of 3. There we go, there's our 3. And we have 3 terms. 5x cubed, that's the first term. Second term is negative 30x squared. And third term is 45x. Alright. Our next one. It is no, because x x could be a negative number, it could be a positive number. That's actually an exponential function. We'll get into that later in the year. Alright, so we're going to take a couple of these. It says to use your graphing calculator to help sketch the graph. Oh, pardon me. So we're just going to look at one or possibly two of them here. We're going to first of all sketch out the roots. So our degree, when we expand this, is definitely going to be a squared because we've got an x first times x first gives us x squared. And when we have two binomials multiplied by each other, we're going to get a trinomial, so we're going to definitely have three terms. And I'm just going to put a little mark there. So x would be 2, 2, 0. And then we're going to go over to 3. And then we're going to put a little mark there. Oh, no, maybe that's 3. No, I don't want that. I want my 3 to be on the other side. Because if we have 3 plus 3, if x is 3, then that gives me 6. So I need 2 and negative 3. So those two. And we're just going to sketch out a real quick graph here. Alright, come on, pen. There we go. Okay. If you want some better points, you can go and put in the graphing calculator and see or create a table of values. Alright, our graphs of polynomials. Graphs of polynomials, they are smooth and continuous. There cannot be any gaps, breaks, holes, or sharp turns. So, on that one up above, when it said that it was a polynomial function, the one that we could not factor with the negative 15, we can put that in the graphing calculator. And if it does not meet this criteria, then we can say it is not a polynomial function. Right. So, alright, this one right here, we're going to look at it. We're going to have an x squared. We're going to multiply by another x. That's going to give us an x cubed. That's our degree. And I'm just going to put a little point there. And my pen's being a little funky, so we'll put that in our calculator to see what it looks like. Okay, come on. Come on, little pen. Sometimes it likes to freeze on me. I think it has to deal with the Bluetooth. There we go. So we're going to use our graphing calculator to sketch the graph without any y-scale. We're not going to worry about the y-scaling on it. Alright, and let's come on back down here. Now I can get my pen to work again. Alright, your domain on a polynomial will be from negative infinity to positive infinity. And the end behavior of the polynomial will be the same as the power function of the same degree. So we've got a single root. We're just going to come up with x minus 1. That would be your linear parent function, or a linear function. And so that's going to be linear. Our ends are going to be pointing away from each other. And we know that it goes on for infinity. There's no gaps, no bumps, no holes, no sharp turns. Okay, it won't look like that. Alright, so we're going to use this term, x minus, this factor, x minus 1. We're going to have a double root. So when I do x minus 1 times x minus 1, I'm going to get x squared. I'm going to get a negative 2x and a positive 1. Going to be quadratic, okay? Oh, they're fine. Let's do it one more time. X minus 1 times x minus 1 times x minus 1. And basically all I want to know is what's going to go on with my parent function at this time. It's going to be cubic. That's what our cubic function looks like. Alright.